What was before the Big Bang? A question every school kid asks, and one that has no answer. Not, we don't know yet, just, no answer exists. But let's go in order. Or not. I haven't decided yet. Here's something that breaks your brain. You're standing on a shore, ocean, infinite. You throw a stone, ripples spread. In a minute, the whole horizon. In an hour, emptiness all around. Now, rewind. The ripples come back together, to a point, to a splash. The Big Bang is that splash. Except the ocean is all of reality, and the splash happened 13.8 billion years ago. So, the question, what was before the splash? And here's where it gets weird. Physicists say the question is meaningless, not because we're stupid, because before didn't exist. Time began with the Big Bang, not from something, just boom, and it started. This isn't philosophy, this is Einstein's equations. But to understand it, you need to rewind history even further, to the early 20th century, when physics was just starting to realize the universe is not a static box. Before Einstein, everyone was sure, the universe is eternal. It always was, it always will be. No beginning, no end. Seemed obvious, philosophically and physically. Then Einstein wrote his equations for general relativity, and they showed something strange. The universe in them isn't static. It's either expanding or contracting, no third option. Einstein didn't want to believe it. He was sure the universe was stable, so he added the cosmological constant, a kind of brace, to keep the universe from moving. Then came Hubble, Edwin Hubble, an astronomer on Mount Wilson in California. In 1929, he pointed a telescope at distant galaxies and found they're running away. All of them, in every direction. The farther the galaxy, the faster it runs. The universe is expanding. And if you rewind that expansion, everything collapses to a single point, one infinitely dense point. That's your Big Bang. Einstein, when he learned about Hubble, called the cosmological constant the biggest mistake of his life. 80 years later, it turned out he was right. But that's a different story. Back to the main thing. If you rewind, everything collapses to a point. But what does rewind mean? It means time. We're rewinding time, and time is part of the universe. Not a background, not a stage, part. And this is where it gets really weird.
Time is not a background, not a river where events float. Time is fabric, a property of space, curved, stretched, compressed, but fabric, part of the universe. Einstein was the first to get it. In his equations, time can't exist without space. They appear together, disappear together, curve together. And this means something important. If the Big Bang is the point where space-time began to exist, then the question, what was before, isn't just hard, it's meaningless. Like asking, what's south of the South Pole? Time didn't exist before the Big Bang. Not in the sense that it was paused, it simply wasn't there. Like there was no space, like there was no matter, like there was no energy, nothing at all. And this is where I personally get goosebumps, because it means this. Reality has no past, no before. There's only now, which has lasted 13 billion years, plus a bit more. We're used to thinking of time as a river. It flows, it flowed, it will flow. But physics says, no river, just water that appeared at some point. No source, no channel, just water. And we're in it. But wait, if time began with the Big Bang, what triggered it? Where did this point come from? Where everything began? This is where physicists split into several camps. Let me tell you about the main ones. The first camp is quantum, and this is the craziest thing I've heard in physics, and I've heard a lot. Ever heard the term vacuum fluctuations? If not, hold on.
even in complete emptiness, where nothing exists, something is always happening. Pairs of particles are born and die. They borrow energy from nowhere, exist for a billionth of a second, disappear. This isn't a theory. They measured it back in the 1940s. The Casimir effect. Two plates in a vacuum attract each other. Why? Because between them, there's less room for fluctuations, and the plates get literally pushed inward by the pressure of emptiness. Okay, emptiness isn't empty. What's next? Here's what's next. If even nothing constantly gives birth to something, what's stopping an entire universe from being born? Quantum cosmology says, our universe is a fluctuation, a random disturbance in quantum foam that existed before, not in space, not in time, in something that doesn't even have a name. Most fluctuations collapse immediately. Nothing happens. But some expand, become universes. We live in one that didn't collapse. We got lucky, or unlucky, depends how you look at it. Hawking believed in this idea until the end of his life. In his last book, he wrote it straight. There's no need for God to launch the universe, because launching doesn't need a someone, just quantum randomness. And this, by the way, is the most depressing version. Because if the universe is random, then so are we, and our minds, and our questions. Just one of the fluctuations that somehow asks questions about other fluctuations. Dark. But the math works. The second camp says something opposite. The Big Bang is not the beginning. It's a transition. And before it was another universe. And before that, another one. And so on. Forever. This is Penrose. Roger Penrose. Nobel laureate. Serious guy. His theory is called conformal cyclic cosmology. I won't even try to explain what conformal means, just trust me, it's mathematically sound. Here's the gist. The universe expands, galaxies fly apart, stars die. In trillions of years, only black holes will remain. Then they evaporate too. Yeah, black holes aren't eternal either, that's Hawking's discovery. And then, absolute emptiness comes. Not space without matter, just nothing. No space, no time, no anything. Penrose shows mathematically that this emptiness is impossible to distinguish from the state of the Big Bang. They're the same thing, just from different sides of infinity. And then, boom, a new explosion. Next universe, next cycle. We're not the first cycle, and not the last. We're one of the infinite breaths of the cosmos. Exhale, emptiness. Inhale, explosion. And so on, endlessly. Penrose found concentric circles in the cosmic microwave background, that glow left over from the Big Bang. He says these are imprints of previous universes, tree rings, but in the sky. Most physicists argue with him. They say the circles are statistical noise. Maybe. But the fact that someone like Penrose is looking for traces of past universes, that says something. There are other versions too. String theory, for example. In it, our universe is a brain, a three-dimensional membrane, floating in multidimensional space, and it periodically collides with another brain. Each collision is a Big Bang. A universe is born at the moment of impact, expands, cools, and billions of years later, a new collision, new explosion, new universe. Sounds like science fiction, but it's not. It's one of the models seriously discussed at places like Princeton and Stanford. And you know what's the craziest part? In some versions of string theory, there are 11 dimensions. Not 3, not 4, 11. 6 of them are curled up so small we can't see them, but they're there, and inside them, other universes, other realities, other us. What to choose? I don't know, and nobody knows. Penrose says, cycles. String theory says, collisions. Quantum cosmology says, randomness. All three theories have math, all three have supporters, and none is proven definitively.
And the third camp, the strangest one, it says, the Big Bang never happened. We have evidence: cosmic microwave background, galaxy expansion. All of it points to an explosion. But what if the explosion isn't the moment of creation? What if it's the moment when our universe switched from one state to another? The theory of eternal inflation, remember in the last video we talked about bubbles, says this: the universe existed forever, not since some moment, forever, in a state of chaos. No galaxies, no stars, just exponential expansion of emptiness. And at some point in our bubble, inflation slowed down. Energy turned into matter. The Big Bang happened. It was transformation, like water to ice. Same substance, different state. In this picture, the question, what was before the Big Bang, is meaningless. Like asking, what was before the origin of coordinates? The universe has no beginning in time, because time is its property, not an external parameter. You know what amazes me most? Not the theories themselves, the fact that they exist at all. That the human mind, a piece of matter that appeared by chance on a small planet near a yellow star, can ask questions about what happened 13 billion years before it appeared, and get answers written in the language of mathematics. That's either a miracle or a statistical anomaly. I don't know which sounds crazier. Three theories: quantum fluctuation, Penrose cycles, eternal inflation. All three could be right, all three could be wrong. And here's what gets me personally. We're the only beings in the universe who ask this question. Stones don't ask where they came from. Stars don't ask why they burn. Galaxies don't ask where they're going. But we ask. Every time we say, what was before, we do something impossible for the rest of matter. We look backward in time, to a place where time, maybe, never existed. Maybe in 100 years, physicists will find the answer. Or maybe this question will stay open forever. And that's okay, because the main thing isn't the answer. The main thing is that we ask it at all.